Okay, now, go ahead. Go.
Okay, this is the PACBot EOD. It's one of the many payloads we have in the PACBot system. The PACBot robot itself consists of this base chassis here that you see. What we call the EOD payload is this manipulator arm, another payload, fiber optic spooler. We also have two other payloads, the Scout configuration, which is a fixed head that mounts on the robot, and the Explorer configuration, which is a head about the same size as the Scout head, mounts beneath the tracks on a small one-link arm about the same length as this link, which gives the ability to bring the head up and survey. PACBot chassis is a submergible robot. It's rated for a 3-meter depth underwater. The chassis is rated for a 400G impact. When you get up to the arm itself, it's a approximately 2-meter height to the head. The arm's equipped with two-way audio using voice over IP. Has a total of 4 cameras on the robot. One located at the base down here by the turret. It's what we call the turret cam. Good for driving, triangulating when lifting things, negotiating over objects. Equipped also with white light LEDs. What you see here is the speaker system for the two-way audio. And you also have the microphone here located in the front. What you see back here is the fiber optic spooler, one of the many payloads for the robot. It gives us 200 meters of fiber optic communications if we don't want to communicate over RF. When we get here, you'll see these small covers. These cover the payload ports of the robot. There's a total of 8 payload ports on the robot. You have 3 located here in the rear, one of which the fiber optic spooler is located in, 1 located here underneath the manipulator arm, and 2 on either side of the robot. These are the side mounts are primarily used for battery power. Any payload port can be used for interfacing sensors or payloads through the robot. Also, any payload port can also be used to access power. So if you want to adapt some sort of power source through the robot, you can do it through any payload port or interface any sensor or payload.
How much juice can you get out of these?
I'm not sure the exact number.
Probably like 12 volts or something like that.
I think it's 24.
Oh, wow, 24.
Yeah.
And this is the control station over here?
This is the control station. As you see, it's a custom design. This is designed to take a 1-meter fall into concrete at any angle. We have 6 degree of freedom pucks to control a 12 degree of freedom arm. So unlike most that just have forward, back, left, right, we also have rotate, straight up, straight down, straight forward, back, side to side. If you see here, we have a 4-quadrant setup. We have 2 camera views. This is always defaulted to our attack camera, which is a 300 times zoom Sony camera with low light capabilities and stabilization functions. We also have over here in the upper right quadrant is the turret camera you see below. That is indexable to 5 positions using either our toggles or a video select option. We also have 2 additional cameras on this robot which are equipped with white light LEDs that can look back at our head to give us a diagnostics if we're looking under cars, things of that nature. So I'll put that to here. We also have the capability from this screen to also select a full image to enlarge if I'm working with very precise things, want to get a good view of an image. Also, as you come down, you can see here we have an active battery display. The robot, as I said, any payload port can be used to adapt with batteries. Currently, the side ports are the primaries. This robot's configured to have 2 on it. We can add battery straps to put 4. If we were to add 4 batteries onto this robot, you'd see all these battery ports decrease in size, and you'd see an additional slot here giving us a battery life indicator. So we have an active display at all times. Next to it is a 3D rendering of the robot. This is a real-time rendering of the robot with active telemetry back from the robot. So unlike some things that would just say, okay, if I move the robot, everything's saying, okay, this is where the arm should be. It's actually where it is, because if I just take the arm and rotate it, you can see the display change without me giving it any commands. That's just done through active telemetry, through encoders.
Right. Yeah, can you move it around?
Yeah, sure.
Alright.
I'll decrease the speed a little. There we go. As you see, well, I'll show you first. We put this into, another thing we equip the robot with is arm presets. Rather than me sitting there and having to control it by using the controls, saying I want the arm to go here, I can just tell it, go to this position, it's a preset, and it'll automatically configure so I can drive or adjust.
Alright, robot macros.
It's designed to climb a 60-degree incline. Horizontally mobile at 45 degrees. Can climb stairs. The articulating flippers in the front are what give us the ability to climb stairs, overcome several different types of obstacles, climb objects. If you're working in very wet environments, say mud, snow, things like that, they essentially allow you to almost swim through it or pull yourself through. Got a baseball.
Like